Black holes are among the most mysterious and misunderstood objects in the universe. For decades, they've been depicted in movies and popular media as terrifying, all-consuming vacuum cleaners that relentlessly pull in everything around them. They're not cosmic hoovers roaming the galaxy, swallowing up planets and stars indiscriminately. Instead, they follow the same fundamental laws of gravity that shape everything else in the universe, including our own sun and Earth. To give you an idea of just how extreme this is, imagine compressing the entire mass of the Earth into a sphere just a few centimeters across. The gravitational pull would be so intense that anything nearby would be drawn toward it, unable to escape. Now scale that up to a star many times the size of our sun, and you have a black hole. One of the most famous examples of a black hole is Sagittarius A*, the supermassive black hole at the center of our Milky Way galaxy. It's about 4 million times the mass of our sun, yet it's been sitting there for billions of years without sucking in the galaxy. In fact, our entire Milky Way orbits around it without being pulled inside. This alone should be proof that black holes don't behave like vacuums. The term suck implies an active force, like a vacuum cleaner pulling in air, but black holes don't actively pull things toward them, they just have extremely strong gravity. Think of the sun, it's incredibly massive and its gravity keeps Earth in orbit around it. But does it suck Earth in? No. Earth moves in a stable orbit because of the balance between its momentum and the sun's gravitational pull. Now, imagine replacing the sun with a black hole of the exact same mass. Would Earth get sucked in? No. Earth would continue orbiting in exactly the same way. The only difference is that there would be no sunlight, which would be a much bigger problem for life than any gravitational changes. Objects only fall into a black hole if they pass a critical boundary called the event horizon, the point at which the escape velocity exceeds the speed of light. If something is far enough away, it can continue to orbit normally, just as planets orbit stars. The event horizon is often mistaken for the surface or the mouth of a black hole. But in reality, it's not a solid boundary, it's simply the point beyond which nothing can return. To understand this, imagine standing at the edge of a waterfall. If you stay far enough back, you can watch the water flow and remain safe. But if you get too close, crossing an invisible boundary, you reach a point where the current is too strong to escape, no matter how hard you swim. That's exactly what happens at the event horizon of a black hole. Once something crosses it, all possible paths lead inward. However, to an outside observer, an object falling into a black hole appears to slow down and redshift, as if time itself is stretching. This is because of the way black holes warp space and time, an effect predicted by Einstein's theory of general relativity. Rather than being destructive monsters, black holes actually play a key role in shaping galaxies. At the center of most galaxies, including our own, there exists a supermassive black hole that helps regulate the movement of stars and gas clouds. Some of the brightest objects in the universe, called quasars, are actually black holes feeding on nearby material, emitting enormous amounts of energy in the process. Black holes are also believed to play a role in galaxy formation. To sum up, black holes don't suck. They pull with gravity just like any other massive object. If the sun became a black hole, Earth would still orbit normally. The event horizon isn't a mouth, it's a boundary where gravity becomes inescapable. Black holes are essential to the evolution of galaxies and the universe. So, the next time you hear someone say that black holes are dangerous vacuum cleaners roaming the galaxy, you'll know the truth. They are incredible objects that warp space and time, but they follow the same rules of physics as everything else in the universe. Black holes are among the most fascinating and extreme phenomena in the cosmos. But far from being cosmic terrors, they are fundamental pieces of the universe's puzzle. And as we continue to study them, we may one day uncover even deeper truths about the nature of space, time, and perhaps even the possibility of traveling through black holes to other parts of the universe. For now though, we can simply admire their power and mystery from a safe distance. What do you think? Are black holes more terrifying or fascinating? Let us know in the comments. And if you enjoyed this video, make sure to like, subscribe, and explore more cosmic mysteries with us.